thank you very much for the invitation onto your stand here at AMB 2018. I tell you what, this is a pretty impressive machine. There's not many like this around the show. Would you firstly, for our audience, just tell us about this machine, give us an overview of what it actually is?
First of all, the most important thing is it's twin-spindle. We have the same thing as a four-spindle as well. And the pallet change works different. As you said, typically you lift the pallet, switch it around, but here we have like a drum. And then we have what we call a fourth axis on both sides of this drum, like a chicken grill. And that's how we work. You could also add a fifth axis to it. The driver for doing it like this, our fixtures are always kept in two hands, and this way very strong and supported from both ends. That's the thing, and it goes...
It's a much stiffer construction, but it strikes me by watching it, it's incredibly fast as well.
It is also very fast, because stiffness doesn't mean a lot of weight. You can design your stiffness in your system and still be fast. And that's important, because where we are with these machines, it's automotive high volume production, so every half second counts.
That's what I was going to go on to. What this really is about a machine that you want to minimize the time that the spindle is not cutting metal.
Not cutting. I mean, that's the whole game. Not making the tool run faster all the time, because then your tool costs go up. It has to be a good balance, but the machine has to be able to give you the shortest non-cutting time as possible.
I mean, we'll see obviously on the video over what we're talking about, how fast this is. But when we get into this league, we start talking about jerk rates, acceleration. Just give us a very quick indication of what that is on here.
I mean, this is a ball screw machine. We have the same models as linear motor machines, which give you even a higher acceleration. Here we're talking around 1G. On the linear motor machines in Z we have 2G, 1.5 in Y and 2G in Z. So hitting this nice E-stop button is not an option, because you're not fast enough to get a crash. It's a little bit like driving let's say a Vauxhall or driving a Porsche. Here you want to be a little more careful, because the Porsche is faster, but you have to be aware of what you're driving.
Yeah, you're alluding to the automotive industry there, and I would say that this is predominantly where these machines fit, is that right?
Yeah, absolutely. The automotive uses that kind of machines since a long time, but there's also pneumatics, hydraulics industries, which we're looking forward to or using or having as customers. It's a small portion. We just started to look into medical parts, because that seems to be an industry where we can have some customers with that thing as well.
Reiner was telling me earlier they sell 400 machines like this a year, which is an incredible number. But the main reason for this machine here at the show is actually what we're going to look at here.
We should go around and show you this. What we have done, because automation and plus another thing we have here on the show, Industry 4.0 oriented, our own platform. But here we are showing that we as a machine tool maker, of course, likewise can make an automation which is completely integrated in the machine. It's a structure on our machine structure. So you lift it up, it comes in one piece, it's a plug and play system. So you don't worry about any geometries on your automation system, yet also very, very compact. Another thing, compact, floor space saving. Floor space means money. And another point, still accessibility.
Well, let's see if we can open this door now.
So when we open this door, you see I'm tall, right? I'm 1.9 meter, and I can walk up. Let me do this. I can walk up and work here on the fixture like there was nothing in between. And that's important for day-to-day work, for the shop floor, to be able to handle it, to have good ergonomics and accessibility.
I think that's a big factor. I think often when machine tool companies are trying to integrate automation, they overlook actually that all they're focusing on is getting parts in and out of the machine, but what about the rest?
What about the rest? And the rest is what takes time over the years and makes it cumbersome for the people to work with the equipment. And I repeat, I'm tall, and we found the most optimum situation for a robot to be and get access to the fixture. You could bring a forklift, you can have a crane and take things, a fixture or parts out, and it's still super.
If you were an SW customer and you have one of your machines, can you interface this onto an existing installation?
We're going to make one version which is a lookalike of this. From the outer skin, it's going to look alike. Here this one hangs on, is attached to the machine structure. The other one has to be mounted on the floor, but you will see no difference.
What's also interesting here is I'm looking at this and thinking, okay, you've only got four parts in here, but if we walk round to the back,
so it would not just be good enough to have the 4 parts. Yes, it's a help, but here we have a stack of different plates where we load parts independent. And the important thing here is this works independent from the robot working on this one pallet inside. So I open the operator would open this door, actuating here, taking finished parts out, putting same parts in or different parts. You can have in every layer same or different parts, so you're very efficient and not stopping your machine on the other side. And also the flexibility of that system is always a given.
I think they've taken space into account again as well here, haven't you, to stack this in this way?
Yes, here we have this what I call the stacker, and it's actually an NC axis which lifts that. So it's a really machine tool built thing, and not something where you could have maybe let me say a more homemade. This is designed, engineered. And the option with this is as well, if you don't want this stacker and have rather a conveyor belt or something, we take this out and you run without any changes to the robot. The robot position remains the same and you run a conveyor through.
I think this is all absolutely fantastic, and I think your detail here has really shown our audience what you're capable of at SW. What in your head would be the uptime of this type of solution? Is it 99%?
The uptime of this, everybody knows that robots themselves have an extremely high uptime of 99%. It comes more about the complexity, what you have, let's say, in the work, but pulling it in and out here, a simple tray. There is no motor. The only action comes from the robot. So the system will give you the same uptime as the robot.
So the machine and the automation all together, you're pretty much removing metal 100% of the time.
Yeah, absolutely. Because the thing feeds itself. Some people call it lights out. You switch the lights out, and a shift later you go back, and your parts are done. And that's what we are showing here. And we made it in-house. There is nothing. I mean, sheet metal is done somewhere else in the end from a manufacturing side, but all the designs going into that is our.
Brilliant. Thank you very much, Reiner. Fascinating insight into this. 400 machines a year these guys are selling. And in fact, Reiner was saying to me earlier that the biggest customers have upwards of 200 machine installations. Really great business. Thanks for your time, Reiner.
Thank you. Thank you very much for coming.